And welcome back. A long time no see. We're looking at similar here now, the ideal gas law, and now with density. So ideal gas law again, that's PVnRT, PV equals nRT. Density, hopefully you remember, take a moment to think about it. Density would be our mass over volume. So D equals M over V. So we'll be using those two together here. So let's look at a couple things about that. Let's say if we got an example, what is the density of a sample of carbon dioxide gas at 645 torr and negative 19 degrees Celsius? So we're trying to find the density of a sample of carbon dioxide. And of course, pause as we're going along to catch up, pause to go ahead and try some stuff out on your own before I tell you what to do. Check and see how well you're getting things or figuring it out on your own. That's always good. Our density, that's what we're looking for. Density is mass over volume, and we can look at the stuff we're given. There's not a lot of information given there. Neither of those numbers, at least in the problem, are mass or volume. So it looks at first like we don't know a whole lot. We got a density, we got a temperature, but we do have one other key piece of information here that's given. It's not a number, but we are told that our gas is carbon dioxide, and you hopefully know the formula of carbon dioxide is CO2. And another thing that's really useful then that we know is that we're looking for mass over volume. Well, we could look up the mass of carbon dioxide on our periodic table. You might even know it because that's one that shows up several times without having to look it up. Maybe you remember, or you could calculate out that it's 44.009 grams per mole. That's our molar mass of carbon dioxide. And if I look at that there, 44.09 grams per mole. That's 2 grams and moles that's talking about there. So what we're going to do is we're going to pull that apart. So you might want to stretch a little bit, make sure your arms are loose, you're not going to hurt yourself. We don't want to get hurt. We're going to take those grams and those moles, we're going to pull it apart into 2 separate things. Ready? Set. There we go. We got 44.009 grams, and that's per 1.0000 moles. I just used the same number of sig figs for the moles as the grams had, if you're worried about the sig figs part. So that gives us 2 pieces of information there. Just knowing that it was carbon dioxide, we could figure out then our grams and our moles. And now we have quite a bit here. We got grams, moles, we got our pressure, and we got our temperature. Those pressures and temperature needs to be in Kelvin. If I add 273 to that negative 19, what would that give us? That would give us 254. We need to convert that into atmospheres if we're going to do anything with our ideal gas law. So you should probably pause and do that quick setup and convert. What would that be in ATM? Make sure you know how to do that. We'd be setting up our bridge, torr, and a millimeter mercury, the same thing. So we know, or you should know, or be able to look up that there are 760 millimeters of mercury per 1 atmosphere. So the same idea then, 760 torr and 1 atmosphere would go together. So I'm dividing by 760, and that should give us 0.848 ATMs. My page here is getting a little cluttered, so I'm going to go on to another page here, just keeping our mass, our moles, our temperature, our pressure now. So I think we've got enough information here. We can use our ideal gas law, PVnRT. We're not going to use the 44.009 grams, that's the mass, but we can use the 1 mole, the 254 Kelvin, and the 0.848 ATM. We can plug those in to our appropriate locations in that equation. Solve for our volume by dividing both sides by 0.848. I'm not going to write that on this one, but that's what we'd be doing. And that should give us 24.6 liters. Make sure you know how and why that volume is 24.6 liters. And what was our original question? If you look back in your notes, we'd be asked for what is the density of this gas. Density is mass per volume. And now I know the mass, 44.009 grams, and I know the volume, 24.6 liters. So I can put those 2 together, mass over volume, divide, and I believe we should have, looking back over all the problem, 3 sig figs, and that should give us 1.79 grams per liter as our density. So hopefully not too bad, not too scary. There's a few steps in there, but you can handle it. You're all, mostly all of you are capable of handling difficulties without crying too much. One more thing before I close off here. I just want to look at sort of similar to what we did with the molar mass for carbon dioxide. If you're given in a problem something like 4.68 grams per liter, that's one of your givens in an example, and you'll get, I don't know if that exact number, but you'll get a density given to you in one or two of your problems on your assignment. What are you going to do with that? Same idea as what we did with the molar mass. That's actually going to not just be one thing, that's going to give us two things. Make sure you stretch first, but you're going to pull those two apart and get two different things, a grams and a liters. So you pull it apart, and you get 4.68 grams, and then that's going to be 1.00 liters. And you have now two things, a mass and a volume that you can go ahead and use for doing whatever it is you need to do, your ideal gas law, your molar mass, whatever it might be. You got those two pieces of information that you get out of that one given there. So good luck with all that good stuff, and it's fun and it's awesome. Remember on your assignment, a lot of the stuff is going to be not just what I talked about in the previous video, but also mixing in some of the stuff from what we had done previously. So it's not just all density, molar mass stuff. So remember, don't forget everything that you should have learned already. Good luck.